Our universe might be just a single page in an infinite cosmic library. We are about to dive deep into the 30 shocking secrets of the multiverse theory, a journey that will completely shatter your perception of reality. You will uncover scientific evidence and philosophical implications that challenge everything you think you know, from parallel versions of yourself to realms where the laws of physics are utterly alien. How could your every choice be creating another world, and what mysterious force is pulling entire galaxies toward the edge of our cosmos? Are you prepared to question the very nature of your existence? The very fabric of reality might be branching at every single moment. This is the first shocking secret, the many worlds interpretation. In the 1950s, a brilliant physicist named Hugh Everett proposed a radical answer to one of science's greatest puzzles. He suggested that the bizarre rules of the quantum world apply to the entire cosmos. At the quantum level, particles exist in a state called superposition, meaning they are in all possible states at once until someone measures them. The traditional view is that this cloud of possibilities collapses into one single outcome when observed, but Everett said no collapse ever happens. Instead, he proposed that every possible outcome of a quantum event does happen, just in a newly formed separate universe. Think of reality not as a single line, but as an endlessly branching tree. Every time a particle could spin up or down, or every time you make a choice, the universe splits. There is a world where you turned left and another, equally real world where you turned right. This even redefines the famous Schrödinger's cat thought experiment. The cat in the box is not both dead and alive in a single, paradoxical state. According to many worlds, there are two separate universes the moment the box is opened. In one, the observer finds a happily alive cat. In the other branch of reality, a different version of that same observer finds a dead cat. Both events are real, happening in parallel worlds that have just diverged. This interpretation boldly attempts to solve the measurement problem in quantum mechanics by removing the mysterious collapse of the wave function. It suggests that nothing is ever truly random, and every possibility, no matter how small, is realized in its own distinct cosmos. The implications are staggering, creating a multiverse of infinite variations where every story that can be told is being lived out somewhere. This infinite branching of worlds is not the only path to a multiverse. There is a second, perhaps even more profound secret rooted in the very birth of our cosmos. The theory of cosmic inflation, our best explanation for the universe's large-scale structure, does much more than just solve a few cosmological puzzles. It inevitably gives rise to a multiverse. To understand our universe is to see it as a single bubble in a frothing, unending cosmic ocean. Cosmic inflation proposes that a fraction of a second after the Big Bang, space itself underwent a fantastically rapid exponential expansion, smoothing everything out and making the cosmos so remarkably uniform and flat. But the most mind-bending part of this theory is the idea of eternal inflation. The process that inflated our local universe may not have stopped everywhere. Think of it like a pot of boiling water that never stops boiling. The inflating space is the bubbling water, and our universe is just one bubble that formed and stopped inflating internally. Everywhere around us, the greater meta-universe continues to expand at an unimaginable rate, spawning countless other bubble universes, each with its own separate pocket of spacetime. These are not branches of a quantum tree, but entirely distinct cosmic domains, isolated from one another forever. The creation mechanism for these bubbles is tied to the quantum world. During inflation, tiny quantum fluctuations, those ghostly pops of energy from the vacuum of space, were stretched to enormous sizes. In our universe, these stretched fluctuations became the gravitational seeds for all the structure we see today, the galaxies and clusters of galaxies. But in the context of eternal inflation, these quantum events can also trigger the formation of entirely new bubble universes. Each new bubble could have different fundamental properties. The strength of gravity, the number of dimensions, even the types of particles might be set randomly as a bubble forms. This means most of these other universes could be utterly alien, completely hostile to life as we know it. We may even have evidence for this staggering idea imprinted on the oldest light in the sky. The cosmic microwave background radiation, the afterglow of the Big Bang, is like a baby picture of our universe. Scientists have meticulously studied its faint temperature variations, looking for any anomalies. One tantalizing possibility is that certain unusual patterns, like large cold spots, could be the cosmic bruises, the fingerprints of our universe gently colliding with a neighboring bubble universe in the distant past. Our entire observable cosmos, with all its hundreds of billions of galaxies, might just be one quiet region in an infinite, inflating froth of realities. Yet this bubbling cosmic ocean of universes is not the final layer of the multiverse. The third shocking secret emerges from the most ambitious attempt to unify all of physics, string theory. It makes a prediction so vast it defies human comprehension. String theory suggests the fundamental building blocks of reality are not point-like particles, but unimaginably tiny, vibrating strings. For the math of this theory to work, it requires more than the 3 spatial dimensions and 1 of time that we experience. It demands extra dimensions, perhaps 6 or 7 more, all curled up into a space so small we cannot perceive them. How these extra dimensions fold and curl is a process known as compactification, and here is where the landscape of possibilities becomes truly astronomical. The number of different, stable ways these dimensions can curl up is estimated to be around 10 to the power of 500. That is a 1 followed by 500 zeros, a number so immense it exceeds the number of atoms in our entire observable universe. Each distinct way of curling up the dimensions defines a unique vacuum state, which in turn dictates the laws of physics for that universe. The strength of gravity, the mass of an electron, the very existence of atoms, all of these fundamental constants are set by the geometry of these hidden dimensions. This string theory landscape gives us a multiverse of almost limitless variety, where the laws of nature are not a single, elegant set of equations, but a cosmic lottery. This leads us directly to a profound and controversial philosophical idea, the anthropic principle. If the multiverse contains 10 to the power of 500 different universes, each with random physical laws, then the vast majority of them would be stillborn. Universes where gravity is too strong for stars to form, or where atoms are too unstable for chemistry to occur. We find ourselves in a universe with just the right constants for life, not because it is special or designed, but simply because we could not possibly exist in any of the others. We are a product of our address in the multiverse. This idea is deeply unsettling to many physicists. It suggests that the dream of a single, beautiful, final theory of everything that uniquely predicts our universe might be an illusion. Instead, fundamental physics could become a catalogue of possibilities, a map of a near-infinite landscape where we just happen to live in one of the very few habitable zones. But this cosmic lottery of physical laws is not the final frontier of reality. The fourth shocking secret pushes the idea of a multiverse to its ultimate, logical extreme. It is called the mathematical universe hypothesis, proposed by the physicist Max Tegmark. His idea is deceptively simple, yet its implications are perhaps the most radical of all. He suggests that our physical reality is not merely described by mathematics, it actually is mathematics. Think about that for a moment. We use math as a tool to model the universe, to predict the orbit of a planet or the behavior of a subatomic particle. Tegmark turns this completely on its head. He proposes that the universe itself is a mathematical structure. You, me, the stars, everything we perceive is just a complex web of mathematical relationships and objects. If this is true, then it leads directly to a level 4 multiverse, a reality of truly unimaginable scope. In this view, every mathematical structure that is logically self-consistent is not just a hypothetical idea scribbled on a chalkboard. It is a real, physical universe. A universe with 5 spatial dimensions is just as real as our 3-dimensional one, because the geometry of 5 dimensions is mathematically consistent. A universe where the rules of hyperbolic geometry govern the shape of space is out there, existing. This means that every story, every fantasy, every conceivable world that can be described without logical contradiction is not just possible, it is mandatory. It must exist somewhere in the grand ensemble of mathematical reality. The universe where you are a pirate sailing an endless sea, the universe made entirely of crystal spheres, the universe where time runs backwards. If they can be coherently described by a set of mathematical rules, then they are as real as the one you are experiencing right now. This transforms the multiverse from a vast collection into something absolute and complete. It is not a random assortment of bubbles or branches, but a perfect, infinite catalogue of every possible form of existence. The only limitation is that a universe cannot contain a logical paradox like a square circle. Anything that does not break the rules of logic is real. This idea forces us to confront a deeply philosophical question. Why does our particular mathematical structure feel so solid and tangible, while others seem like mere abstractions? The answer might be that consciousness itself is a form of mathematical pattern. Our perception of a physical world is simply how our brains, which are themselves mathematical structures, interpret the specific mathematical relationships that define our home in this ultimate multiverse. The sheer scope of a mathematical multiverse is almost beyond human thought, but there is another theory that brings parallel worlds shockingly close to home. M-theory, a leading candidate for a theory of everything, proposes that our entire universe might be a 3-dimensional membrane, or brain for short, floating within a higher dimensional space called the bulk. Think of our cosmos not as an island, but as a single sheet of paper floating within a vast, unimaginably thick book. Other brains, other parallel universes, could be other pages in that same book, separated from us by a gap as small as a millionth of a billionth of a meter. Yet this tiny distance exists in a direction we cannot point to or move in, a direction folded away in an extra dimension. We are trapped on our brain, unable to perceive these other worlds, even if they are right next to us. This leads to one of the most profound ideas in modern cosmology. What if our Big Bang was not a singular beginning from nothing, but the aftermath of a cosmic collision? The cyclic model of the universe suggests that our entire cosmic history, from the hot, dense state to the present day, was initiated when 2 of these brains smashed into each other in the higher dimensional bulk. The incredible energy of that impact, that ancient brain collision, became the fire of creation for everything we see. This model even suggests the universe undergoes endless cycles, with brain collisions fueling new Big Bangs every trillion years or so. But how could we ever find evidence for these invisible neighboring worlds? The answer might be gravity. In the brain multiverse, the fundamental particles of matter, like electrons and quarks, are like tiny strings whose ends are pinned to our brain. They cannot leave our sheet of the cosmic book. Gravity, however, is different. It is a manifestation of the geometry of space-time itself. In these models, the graviton, the hypothetical particle that carries the gravitational force, could be a closed loop of string, free to drift into the bulk. This means gravity, and only gravity, could leak from our brain to a neighboring one, or from a neighboring brain into ours. This leakage would make gravity appear mysteriously weak in our universe compared to the other fundamental forces. Scientists are now conducting incredibly sensitive experiments to detect the presence of these extra dimensions by looking for deviations in the force of gravity at microscopic distances. If gravity is seeping into another reality just a fraction of a millimeter away, our most fundamental understanding of the cosmos would be forever transformed. This unsettling idea pushes the logic of branching worlds to a terrifying personal extreme. Imagine a version of you is placed in a laboratory, seated before a device that is linked to a single radioactive atom. The device is programmed so that if the atom decays within a certain time, a lethal mechanism is triggered. If the atom does not decay, the device does nothing and you survive. This is the setup for the quantum suicide thought experiment. According to the traditional Copenhagen interpretation of quantum mechanics, this is a simple, if grim, game of chance. The atom has a 50% probability of decaying, so there is a 50% chance you die. But the many worlds interpretation paints a profoundly different picture. The moment the quantum event is measured, the universe splits. In one branch, the atom decays and the observer dies. In the other branch, the atom does not decay and the observer lives. Now consider the subjective experience of the observer inside the experiment. After the device is activated, what do they perceive? In the branch where they die, their consciousness ceases instantly. But in the branch where they survive, they are perfectly aware and continue to exist. From that surviving observer's first-person point of view, the experiment was a success. They are still here. Now reset the experiment, run it again and again and again. Each time the universe branches, in half of the new realities, that version of you dies. But there is always at least one branch, one stream of consciousness where the quantum event went your way and you survive. No matter how many times you repeat this lethal test from the perspective of your continuing awareness, you will always find yourself alive. This leads to the shocking suggestion of quantum immortality. For any conscious observer, no matter how low the odds of survival in a quantum event, there will always be some branches of reality where they do not die. Your personal stream of experience, your consciousness, seems to be forever tied to those branches where you continue to exist. It is as if you are locked into a path through the multiverse that avoids your own death. The philosophical ramifications of this are deeply disturbing. Does this mean you could survive a seemingly certain death, like jumping from a skyscraper? In the vast majority of resulting universes, you would die on impact, but the many worlds logic suggests there could be an astronomically rare branch where a perfect confluence of quantum events creates a miraculously survivable outcome, perhaps a sudden gust of wind or a series of improbable bounces. Your consciousness would only follow that one incredibly unlikely path. Critics of this idea are quick to point out its flaws. The thought experiment relies entirely on the subjective experience of a single observer, ignoring the objective reality witnessed by everyone else. To all outside observers, you would appear to have died in almost every branch. The experiment also assumes that consciousness can only follow one continuous path, which is a major unsolved problem in itself. Furthermore, it raises serious ethical dilemmas. Does this idea promote a dangerous sense of invincibility? The answer from physicists is a resounding no, because the you that continues is just one version among countless dead ones. The true value of quantum suicide is not as a guide for living, but as a stark philosophical tool that forces us to confront what reality and consciousness might truly be within an infinite multiverse. It asks a question that is both terrifying and mesmerizing. Are we, from our own point of view, essentially immortal travelers, forever skipping across the branches of reality where we remain alive? The unsettling possibility of quantum immortality forces us to question the very boundaries of our own universe. But what if we could find physical evidence that something beyond our cosmic horizon is actively pulling on us? Astronomers have made a discovery so strange it has been named the dark flow. Across vast intergalactic distances, hundreds of galaxy clusters are streaming in a coordinated motion, all hurtling toward a single, mysterious point in the cosmos at incredible speeds of over 2 million miles per hour. This is not the random drift of galaxies, but a coherent river of matter flowing in one specific direction. This motion presents a profound cosmic puzzle. According to the bedrock principle of modern cosmology, the universe should be largely uniform on the largest scales. Matter and energy should be distributed evenly enough that there is no preferred direction, no cosmic north pulling everything toward it. The dark flow blatantly contradicts this. The gravitational pull from all the visible matter we can map in our observable universe is utterly incapable of causing this massive directed stream. Something else, something we cannot see, must be responsible. The most shocking hypothesis is that the source of this immense gravitational tug lies entirely outside our universe. Picture our cosmic bubble floating in the greater multiverse foam. Now imagine a neighboring bubble universe, unimaginably large and massive, existing just beyond the edge of our observable spacetime. Its immense gravitational field, leaking through the fabric that separates our realities, could be reaching into our cosmos and pulling on everything within its reach. We are like fish in a pond, all being drawn by a current whose source is a massive waterfall just beyond the horizon we can see. This is not just a wild speculation. The patterns observed in the dark flow align with what such an external gravitational pull would look like. The debate among cosmologists is fierce. Skeptics suggest the data could be an artifact or caused by some unknown local effect. Yet the evidence persists, a ghostly current in the cosmos that points a finger toward the multiverse. The future of this mystery rests with new generations of space telescopes, which will peer deeper into the cosmic microwave background, searching for the definitive imprint of a gravitational hand from another reality. This cosmic current pointing beyond our horizon forces us to confront a truly unsettling question about our own place in the grand scheme. Could the very order we perceive be nothing more than a fleeting, random accident? This is the terrifying core of the Boltzmann brain paradox. It begins with a simple thermodynamic principle that systems tend to move from order to disorder. A shattered glass does not reassemble itself, and a hot cup of coffee left alone will always cool down. Yet, in an infinitely vast and eternal multiverse, the statistical rules of probability undergo a profound shift. Even the most wildly improbable events are not just possible, they are absolutely guaranteed to happen given enough time and space. The spontaneous, random assembly of atoms into a fully formed, self-aware brain, complete with a lifetime of fabricated memories and sensory experiences, is astronomically more likely than the gradual, ordered evolution of an entire 13.8 billion-year-old universe with galaxies, planets, and billions of real, biologically evolved beings. The math is chilling. In a truly eternal and infinite reality, there should be vastly more of these disembodied Boltzmann brains, momentarily flickering into existence from the quantum foam of empty space, than there are genuine, embodied observers like you and me. Each one of these isolated brains would, for its brief instant of consciousness, hallucinate a perfectly coherent reality, perhaps one exactly like the world you believe you are living in right now. It would have memories of reading this script, of a childhood, of a life that never actually happened. This thought experiment casts a long shadow of doubt over everything we take for granted. How can you be certain that you are not a Boltzmann brain, having just popped into existence a moment ago with a complete but entirely false set of memories and perceptions? The paradox forces cosmologists to search for a resolution, often by looking back to the very beginning. Our universe is not in a state of maximum disorder. It started in a state of incredibly low entropy, a highly ordered and specific configuration at the Big Bang. This special initial condition is what allowed for the long, structured cosmic history that led to us. If our universe is just one bubble in an inflating multiverse, perhaps the laws of physics in our particular bubble naturally favor these low entropy beginnings, making real, evolved observers like us far more common than random, disembodied hallucinations. The search for an answer to this paradox is not just an academic exercise. It is a fundamental struggle to determine whether our reality, with all its rich history and shared experiences, is the genuine article or the most elaborate and improbable of cosmic mirages. The terrifying possibility of being a fleeting cosmic hallucination forces us to confront a strange and beautiful fact about our universe. Its fundamental rules seem perfectly calibrated for our existence. This is the ninth shocking secret, the fine-tuning problem. The very laws of physics appear to be balanced on a razor's edge. Consider the strength of the force that binds atomic nuclei together. If this strong nuclear force were just a few percent stronger, the universe would have fused all its hydrogen into helium in the first few moments after the Big Bang. There would be no hydrogen left to form water or to fuel the long-lived stars that life depends on. If that same force were slightly weaker, atomic nuclei would never have formed at all. We would have a cosmos of scattered protons and neutrons with no atoms, no chemistry, and no possibility for planets or people. Another critical number is the cosmological constant, which governs the energy of empty space and the acceleration of the universe's expansion. If this value were a little larger, the repulsive force would have been so powerful that it would have torn galaxies, stars, and even atoms apart before they could ever form. If it were slightly smaller and negative, the entire cosmos would have collapsed back into a superheated crunch shortly after it began. The universe would have been stillborn. The list of these precisely set constants is long and deeply unsettling. It is as if someone carefully dialed in dozens of independent cosmic knobs to exactly the right values to make life possible. This apparent perfection has led some to propose the existence of a cosmic designer, an intelligence that set the rules specifically for us. Yet for scientists seeking a purely physical explanation, the multiverse offers a powerful, if speculative, alternative. In a vast multiverse where the fundamental constants are randomly set in each separate cosmic domain, it becomes a statistical certainty that a few universes will, purely by chance, have all the knobs turned to the life-permitting positions. We do not live in a special universe designed for life. We live in one of the extremely rare universes that accidentally allows for life because we could not possibly find ourselves anywhere else. This is the anthropic multiverse in a nutshell. It replaces the question of why the universe is fine-tuned for life with a different answer. It is not fine-tuned. We are simply the lucky winners of the ultimate cosmic lottery, living in the one reality where the random draw of physical laws allowed for our existence. This perspective transforms our place in the cosmos from a central purpose to a fortunate accident in an unimaginably vast and mostly dead ensemble of worlds. That fine-tuning of our universe, which makes our existence possible, leads to a deeply unsettling modern possibility. Our entire cosmos, with all its galaxies and history, might not be a base reality at all, but an elaborate digital construction. This is the 10th shocking secret, the simulation hypothesis, and it forms a unique kind of technological multiverse. The argument begins with a simple projection of technological power. If any civilization in the universe's long history ever reached a sufficiently advanced stage, it would likely possess the computational resources to run incredibly detailed simulations of conscious beings. These would not be simple video games, but fully realized virtual worlds, indistinguishable from reality to the minds inside them. Now consider the numbers. There would be one original, base reality, but potentially billions or even trillions of these simulated universes. From a purely statistical standpoint, the vast majority of all conscious experiences would be happening inside simulations, not in the original world. Therefore, it is overwhelmingly probable that you and I are not living in the base reality, but are instead part of one of these countless simulations. This idea gains even more power when you consider the purpose of such a project. An advanced civilization would not run just one simulation. they would run a vast ensemble of them, each with slightly different physical laws and initial conditions. They would be creating a technological multiverse, a laboratory of realities to study cosmic evolution, the rise of life, or perhaps even for entertainment. In this view, our specific set of physical constants is not a lucky draw from a cosmic lottery or evidence of a designer. It is simply the chosen parameter set for this particular simulation run. The philosophical implications are staggering. If this is true, then the multiverse is not a fundamental feature of nature, but something built, a product of intelligence. It forces us to ask what reality truly is. If every sensation, every memory, and every law of physics can be encoded as information, then is our experienced universe any less real? The feelings you have, the love for your family, the awe at a starry night, all of these are real experiences for you, regardless of whether they are rooted in atoms or in algorithms. This technological multiverse is a profound and testable idea. Scientists have proposed that if our universe is a simulation, there might be tiny glitches in the fabric of space-time, or shortcuts in the code that appear as anomalies in high-energy particle collisions. While no such evidence has been found, the search itself redefines our quest for understanding. We are no longer just creatures looking out at a mysterious cosmos. We might be characters in a story, wondering if we can catch a glimpse of the programmer. While we grapple with the possibility of our reality being a simulation, another theory suggests a hidden cosmos is already woven into the fabric of our own. This is the mirror matter universe, a perfect duplicate of our reality that remains forever just out of reach. The idea emerges not from cosmology, but from the heart of particle physics itself. Scientists have long sought to extend the Standard Model, our current rulebook for the subatomic world, to solve its lingering puzzles. Some of the most elegant solutions require a profound symmetry, a fundamental law of nature that dictates every single particle we know must have a hidden twin. This is not mere antimatter which we can create and study. This is a complete mirror set of particles, a shadow world with its own mirror protons, mirror electrons, and even its own mirror forces. The only bridge between our world and this mirror realm is the faint, universal tug of gravity. Imagine an entire universe of mirror stars, mirror galaxies, and mirror planets, all made of this elusive substance, existing in the exact same space we occupy. You could be sitting in a chair that is also occupied by a mirror version of that chair, and you would never know. Life could have evolved there, with mirror beings looking out at their own cosmos, completely unaware of our existence right beside them. The most astonishing implication of this theory is its potential solution to one of astronomy's greatest mysteries, dark matter. We know that galaxies rotate so fast they should fly apart, held together only by the gravitational pull of unseen mass. For decades, scientists have searched for a new, exotic particle to explain this missing mass with no success. Mirror matter presents a stunning alternative. What if the dark matter holding our galaxies together is not a cloud of strange particles, but the combined gravitational weight of an entire mirror universe superimposed on our own? Our familiar, luminous matter would be just a small fraction of the total cosmic mass, floating like a thin film on the surface of a vast, invisible ocean of mirror stars and planets. This means we are not just surrounded by a hidden cosmos, we are intermingled with it, living in a perpetual cosmic duet with a universe we can neither see nor touch. The violent birth of our universe might not have been a singular explosion from nothing, but a shattering impact with another reality. This is the ekpyrotic universe model, a dramatic alternative to cosmic inflation that paints our cosmic origin as a collision in the bulk of a higher dimensional space. Imagine our three-dimensional brain universe as a vast flat sheet, drifting silently through a hidden dimension. Another brain, another entire universe floats parallel to ours. In the ekpyrotic scenario, these two cosmic membranes are drawn together by an irresistible force, moving slowly at first, then accelerating into a cataclysmic collision. The point of contact becomes a fiery genesis. The immense kinetic energy of that impact is instantly converted into the searing heat and dense soup of matter and radiation that we now call the Big Bang. Our entire cosmic history, from that first hot, dense state to the expansion we see today, was born not in a spontaneous outpouring of energy, but from the wreckage of a cosmic car crash. This model elegantly sidesteps the need for a mysterious period of rapid inflation to explain the universe's smoothness and flatness. Instead, the long, slow approach of the two brains before the collision naturally smooths everything out, ironing out wrinkles and preparing a uniform canvas for the new universe. If the brains had been wrinkled or warped, their gentle, drawn-out contact before the final impact would have stretched and flattened any irregularities, leaving the resulting cosmos remarkably uniform. This process solves the same cosmological puzzles as inflation, but through a completely different and perhaps more physically intuitive mechanism. The most profound implication of this model is its inherent cyclicity. After the collision, the two brains bounce apart, stretched and energized by the event. They then drift away, only to be pulled back together again by the same fundamental force, destined to collide once more in a cycle that repeats every trillion years or so. Each collision ignites a new Big Bang, creating a fresh universe with its own timeline and history. This is not a multiverse of simultaneous bubbles, but a multiverse in time, an endless sequence of cosmic epochs, each born from the ashes of the previous one. Our universe is just the current incarnation in an infinite series of cosmic deaths and rebirths. How could we ever prove such a staggering idea? The answer lies in the faintest ripples in space-time. A brain collision of such unimaginable force would not just create matter and energy, it would send powerful tremors through the very fabric of reality, generating a unique spectrum of gravitational waves. These primordial ripples would imprint a specific pattern on the oldest light in the universe, the cosmic microwave background. Our most sensitive telescopes are now searching for this telltale signature. Finding it would be like discovering the fingerprint of a cosmic neighbor we never knew we had, offering the first direct evidence that our universe was forged in a collision with another reality. That shadow universe interwoven with our own is a staggering concept, but it still assumes a reality built from solid, physical stuff. The 13th secret shatters even that foundation. Our three-dimensional cosmos, with all its depth and grandeur, might be nothing more than a magnificent illusion, a hologram. This is not science fiction. The holographic principle is a rigorous idea born from the most extreme places in the universe, black holes. Physicists studying these gravitational monsters encountered a profound paradox. The fundamental laws of physics insist that information can never be truly destroyed. Yet, if you throw an object into a black hole, it seemingly vanishes from our universe, and if the black hole later evaporates through Hawking radiation, what happened to all the information that object contained? The brilliant resolution proposed by physicists like Gerard T. Hooft and Leonard Susskind is that the information describing everything that falls into a black hole is not lost inside. Instead, it is perfectly encoded, pixel by pixel, on the two-dimensional surface of the black hole's event horizon, the point of no return. The three-dimensional interior we picture is just a projection of that data, like a hologram emerging from a flat plate. The stunning leap is that this principle might apply to the entire universe. Our reality, with its galaxies, planets, and people, may be a holographic projection from a thin, two-dimensional shell that lies at the farthest cosmic horizon. Every event, every particle, every sensation you have is just information being read from the cosmic hard drive at the edge of space and time. This transforms our understanding of reality itself. The fundamental stuff of the cosmos is not matter or energy, but bits of information. Think of the world around you not as a collection of solid objects, but as a cosmic movie screen. You are not looking at the screen, you are part of the image. The depth, the texture, the passage of time, all of it is a magnificent rendering from a deeper, simpler layer of reality. This leads to a breathtaking vision of the multiverse. If our universe is one hologram projected from its own two-dimensional boundary, then other universes in the multiverse could simply be other holograms encoded on entirely separate surfaces. Each bubble universe, each parallel brain, could be its own self-contained projection. The entire multiverse then becomes a vast, interconnected library of information structures, a cosmic archive where each volume is a complete reality. The laws of physics within any given universe are not fundamental. They are simply the rules of the code running on that particular cosmic projector. A universe with stronger gravity is just a universe running different software. This idea forces us to confront the most mind-bending implication of all. Space and time, the very stage upon which the cosmos plays out, are not primary. They are emergent properties derived from the complex relationships between countless bits of information. You are, at the most fundamental level, a pattern of data. Your thoughts, your memories, the feeling of the ground beneath your feet, all are manifestations of a cosmic computation happening on a boundary so distant we can never hope to see it. The solidity of the world is a beautiful, persistent illusion, a holographic mirage of unimaginable complexity. Probability itself shatters inside an infinite multiverse. In a reality where every possible outcome occurs across countless branches, the very idea of chance undergoes a radical transformation. Think about flipping a coin. In our world, we say it has a 50% probability of landing heads, but in the many worlds view, it does not have a probability at all. It simply splits into two universes, one with heads and one with tails. Both outcomes are 100% real for the versions of you that experience them. Now, extend this to events we would call wildly improbable. The odds of you spontaneously teleporting to the other side of the room are so astronomically small that we dismiss them as impossible. Yet, in an infinite multiverse, if there is any non-zero probability, no matter how tiny, that event is not just possible. It is guaranteed to happen in an infinite number of universes. In fact, it is happening right now an infinite number of times. This completely unravels our everyday understanding of luck and statistics. Your lottery win was not a 1 in a million shot. In the grand scheme of the multiverse, it was a certainty for some version of you, while countless others lost. This leads directly to a profound mathematical puzzle known as the measure problem. When everything happens an infinite number of times, how do we define what is common and what is rare? How do we calculate the fraction of universes that contain an Earth exactly like ours, right down to the last grain of sand? The problem is that infinity divided by infinity is undefined. There are infinite universes with your exact copy, but there are also infinite universes where Earth never formed, and infinite more where the laws of physics preclude planets altogether. In an infinite set, counting loses all meaning. You cannot say one type of universe is more numerous than another because both quantities are limitless. This forces physicists to find a way to assign a measure, a kind of weighting, to different types of universes to make any meaningful statements about probability. Without this, the theory risks becoming untestable and philosophically empty. It suggests that for every version of you reading this script, there is another who just won the lottery and another who is king of an alien empire. The unsettling truth is that from the multiverse's perspective, there is no such thing as improbable. There is only what happens and what does not, and in an infinite reality, everything that can happen does. That strange sense of probability dissolving in the multiverse finds a perfect echo in one of science's most enduring mysteries, the spooky connection of quantum entanglement. Two particles become linked, their fates intertwined. You can separate them by the width of a galaxy, and yet, the moment you measure the spin of one, the other instantly snaps into a corresponding state. This seems to violate a cosmic speed limit, the rule that nothing can travel faster than light. How can information seem to leap across the void instantaneously? The answer might not involve any communication at all within our universe. The secret could be that these particles are not two separate entities sending secret messages. They are two ends of the same deeper structure, connected not through our space, but through the higher dimensional bulk of the multiverse. Imagine a worm burrowing deep underground. You see its head pop up in one field and its tail in another a mile away. To someone who only sees the two holes, the worm appears as two separate creatures that move in perfect, instant synchronization. But they are not two, they are one, connected by a hidden pathway in a dimension you cannot see. In the same way, entangled particles might be like the head and tail of a single, higher dimensional object with its true body passing through the multiverse's bulk. This would explain the spooky action at a distance without any need for faster-than-light signals. The connection is already there, a fundamental unity that transcends our limited, three-dimensional perspective. This idea was actually one of the original motivations for Hugh Everett's many worlds interpretation. He sought to remove the paradoxical collapse of the wave function, the moment a probability becomes a certainty. In his view, when you measure one of a pair of entangled particles, the universe does not magically decide a single outcome. It splits. In one branch, you find particle A spinning up and particle B spinning down. In the parallel branch, a different version of you finds particle A spinning down and particle B spinning up. Both outcomes were always real, and the connection between the particles is simply a record of their shared origin before the worlds diverged. This leads to a breathtaking possibility. What we call quantum entanglement might not be a bizarre quirk of our world, but a tiny window, a frayed edge in the fabric of our reality, where we can glimpse the underlying interconnectedness of all parallel worlds. Every time we observe this spooky link, we are not seeing a message travel across space. We are seeing the ghostly outline of the multiverse itself, a reminder that our solitary universe is just one thread in an infinite, woven tapestry of existence. This evolutionary chain of universes leads to a truly Darwinian vision of reality. Our cosmos might not be a static stage, but a living, breathing entity in a constant struggle for existence. This is the cosmic natural selection hypothesis proposed by physicist Lee Smolin. His idea is as elegant as it is radical. What if a black hole is not an end but a beginning? When a star collapses into a black hole in our universe, the unimaginable singularity at its heart might not be a point of infinite density. Instead, it could be a cosmic seed, birthing an entirely new universe in a separate region of the multiverse. This new baby universe would inflate and expand, creating its own space and time with its own set of physical laws. Crucially, these laws would not be an exact copy of its parents. Just as DNA mutates when passed to offspring, the fundamental constants of physics could shift slightly during this cosmic reproduction. The strength of gravity, the mass of a proton, or the cosmological constant could all be minutely different in the newborn universe. This small change is the engine of cosmic evolution. Now consider the consequence: which universes would become the most common in the multiverse over cosmic time. The ones that are the most prolific, the ones best at reproducing. And what is the mechanism for reproduction in this theory? The formation of black holes. Therefore, universes that have physical constants fine-tuned to maximize black hole production would have the most offspring. They would, through a form of natural selection, come to dominate the multiverse population. This offers a stunning alternative to the anthropic principle for explaining why our universe seems so finely tuned. We do not live in a universe optimized for life. We live in a universe optimized for making black holes. The constants are set to values that allow for the long-lived stars necessary to produce heavy elements, and for those stars to eventually collapse into black holes in vast numbers. Life, in this view, is merely a cosmic accident, a byproduct of a universe that is exceptionally good at creating gravitational singularities. This makes a testable prediction. If our universe is a product of this selection, then we should be able to calculate the theoretical maximum for black hole production and find that our own constants are very close to that ideal. Any significant tweak to a fundamental force should, according to the math, result in fewer black holes. This transforms the multiverse from a random, timeless collection into a dynamic, evolving ecosystem where universes live, die, and reproduce, all governed by the simple, powerful logic of selection. We are not just inhabitants of a cosmos, we are living inside a universe that won the evolutionary race by becoming a master of cosmic creation. This notion of an evolving black hole-rich cosmos forces us to confront the most intimate question of all. What if consciousness is not merely a passenger in the multiverse, but its very source? The 17th shocking secret proposes that mind itself is the fundamental fabric of reality, and every conscious being is a creator, spinning off personal branches of existence with every thought and observation. This view, a form of idealism, turns the standard scientific story on its head. We are taught that the brain produces consciousness, a fragile flicker in a mechanical world. But what if consciousness is the ocean and the physical universe, including our brains, is merely a wave upon its surface? This idea finds a strange resonance in the heart of quantum mechanics, where the observer has always played a mysterious, seemingly central role. The act of measurement, of looking, appears to force a fuzzy cloud of possibilities to snap into a single, solid outcome. In this consciousness-created multiverse, that collapse is not a physical event, but an act of focused attention. Your awareness is not a passive receiver of a predetermined world. It is a creative force selecting one path from the infinite branches of the quantum tree and making it real for you. Every time you make a choice, you are not just navigating a pre-existing multiverse. You are actively forging your own unique timeline within it. This leads to a breathtaking vision of reality as a vast conscious network. The entire cosmos is awake, a single, boundless mind experiencing itself from an infinite number of localized perspectives. You are one of those perspectives, a focal point of this universal consciousness having a human experience. The tree outside your window, the stars in the night sky, all are manifestations of this one mind, appearing separate and solid only from your limited point of view. This is not so different from the ancient idea of panpsychism, which suggests that consciousness is a fundamental property of all matter, from an electron to a galaxy. The implications for our own identity are profound. If consciousness is primary, then your true self is not the collection of atoms in your body, but the timeless awareness that is currently experiencing the world through them. Your stream of thoughts and sensations is not generated by your brain. Your brain is more like a receiver, a complex antenna tuning into the specific channel of reality that you call your life. This radically redefines free will. In a purely physical multiverse, your choices might be predetermined by prior causes, playing out across every possible branch. But if consciousness is the ground of being, then your will is a fundamental creative power. You are not a leaf blown by the winds of quantum chance. You are the wind shaping the branches of your own reality with every decision and observation. The universe you perceive is quite literally your story to tell. This transforms the multiverse from a cold, mechanical ensemble into a deeply personal, living tapestry of experience where every conscious moment is an act of cosmic creation. This creative power of consciousness shaping our personal reality confronts a cosmic truth even more fundamental. Time itself may be the grandest illusion of all. Deep within the equations of quantum gravity, a shocking secret lies hidden. The Wheeler-DeWitt equation, a bold attempt to unite quantum mechanics with general relativity, presents a universe without time. In this profound mathematical description, the variable for time simply vanishes, suggesting that the flow of moments is not a primary ingredient of reality. Instead, the cosmos might be a single, unchanging, four-dimensional block. This is the block universe model where the past, present, and future are not sequential. They all exist at once, eternally and equally real. Your birth, your life, and your death are all fixed points in this vast static structure, just as real and permanent as the cities on a map. The feeling that time is passing, that the future is open and the past is gone, is a powerful but persistent trick of perception. Now, place this timeless block within the context of the multiverse. The picture becomes almost impossible to grasp. It is not a single, frozen block, but an infinite library of them. Every possible timeline, every branch of the quantum tree, every variation of history is already written and permanently real. There is a complete four-dimensional block universe for every possible sequence of events. In one block, the Roman Empire never fell. In another, you took a different job last year. All of these complete histories exist simultaneously in a timeless meta-reality. So what is it that we are actually experiencing when we feel time pass? The answer might lie within our own minds. Our consciousness could be like a tiny flashlight beam, moving steadily along one single, predetermined path within this infinite, dark library of frozen timelines. We do not see the entire block at once. We perceive only the illuminated slice we call the present. The memory of the past is our recollection of the parts of the block we have already scanned, and the anticipation of the future is our awareness of the path that still lies ahead in the darkness. This means that change, the very essence of our lives, is not fundamental. It is an emergent property, a story generated by our conscious journey through a cosmos where nothing ever truly changes, because everything that can happen already does forever. Your life is not a process of becoming. It is a timeless pattern of being, a single, unchangeable thread woven into the infinite, static tapestry of the multiverse. The relentless tick of the clock is not a measure of cosmic progress, but the steady beat of your awareness, reading its own eternal story from a script that was always complete. This ultimate ensemble is the 19th shocking secret, a theory that pushes the very idea of existence to its absolute limit. It declares that every single universe that can be logically conceived is not just possible but real. We are not limited to bubbles with slightly different physics or quantum branches of our own history. This ultimate multiverse contains realms where the laws of magic are as real and dependable as gravity is here. There is a cosmos where the gods of ancient myth hold actual power, and another where the rules of your favorite video game define the fabric of reality. A universe composed entirely of sentient light, or one where time flows in a perfect circle, repeating the same events for eternity. Each one is out there, existing. This idea forces us to confront a deep philosophical puzzle. What exactly does logically consistent mean? We can easily imagine a square circle, but that is a logical contradiction, an impossible object. The ultimate ensemble would not include such a thing. But what about a universe with 5 fundamental forces instead of 4? Or a reality where consciousness is a fundamental field like electromagnetism? These are logically coherent ideas, and therefore, according to this hypothesis, they must exist. The boundary between fantasy and reality dissolves completely under this rule. Every novel, every daydream, every myth and legend ever told by humanity describes a real place. The world of Tolkien's Middle-earth is as physically real as our own Milky Way galaxy. The stories of Greek heroes battling monsters are not just tales, they are historical accounts from another cosmic domain. Your most impossible dream, the one you would never dare to speak aloud, is being lived out by another version of you in a universe built to make it possible. This makes reality infinitely more strange, more generous, and more terrifying than we could ever conceive. It means that every story has been told because every story is true. The ultimate library of reality contains every book that can be written, and we have only ever read a few pages from a single, solitary volume. That ultimate library of every possible reality forces a question we have taken for granted since the dawn of science. Where do the laws of physics themselves actually come from? In a single, solitary universe, the existence of these perfect, immutable rules is a profound and enduring mystery. Why is the speed of light exactly 299,792,458 meters per second? Why does gravity obey an inverse square law? We have always assumed these laws are fundamental, written into the very foundation of reality in some permanent cosmic code, but inside a multiverse, this entire perspective shatters. The laws of physics may not be fundamental at all. They could be nothing more than local bylaws, the specific zoning regulations for our particular cosmic neighborhood. Think of our universe as a single city with its own unique traffic rules. One city might require driving on the right side of the road, while another, in a different universe, mandates driving on the left. Neither set of rules is more correct or more fundamental than the other. They are just different conventions that emerged as each city, each cosmic bubble formed. In our case, the local bylaws that govern our reality are the specific strengths of the fundamental forces, the masses of particles, and the number of dimensions we experience. They are not the master laws of a grand creator, but the accidental outcome of a random process, like the particular pattern of a snowflake. This idea is powerfully supported by the string theory landscape, where the way extra dimensions curl up determines the local physics. Our universe just happened to get one particular curl, one specific set of bylaws that allows for atoms, stars, and us. This leads to an even more radical suggestion. What we call the laws of physics might not even be the true, deep rules. They could be low-energy approximations, a simplified user interface for the complex reality operating beneath. Consider the surface of a pond. To a water strider insect, the water behaves according to certain simple laws of surface tension. The insect has no concept of the far more complex laws of fluid dynamics, of currents and pressures and molecular interactions that govern the water's true nature. In the same way, our entire physics, from Newton to Einstein, might just be the surface tension of our cosmic pond. The real, underlying theory could be something vastly more complex and abstract, a theory that does not predict a single set of laws, but allows for a near-infinite variety of them to manifest in different domains. This completely reframes the century-long quest for a theory of everything. Physicists have dreamed of a single, elegant equation that uniquely describes our universe. But if the multiverse is real, that dream might be an illusion. There can be no single theory of everything for the entire multiverse because the multiverse contains every possible thing. Instead, the ultimate theory would be a theory of anything, a meta-law that describes the framework within which all possible sets of local bylaws can arise. It would not predict our specific speed of light or strength of gravity. It would simply allow for them along with every other conceivable configuration. The profound mystery then shifts. The question is no longer why our laws are so perfect for life, but why our particular slice of the multiverse settled into this stable, predictable set of bylaws that we have been lucky enough to decode. This logical conclusion of quantum immortality presents a terrifying ethical dilemma. What happens when someone becomes so convinced by the theory that they decide to test it? The quantum suicide thought experiment is no longer just a philosophical puzzle scribbled on a chalkboard. It becomes a potential blueprint for action, a real-world gamble with the highest possible stakes. Imagine a person, perhaps a physicist gripped by an obsessive need for proof, who constructs a device linked to a quantum trigger. Every minute, the device checks the spin of an atom. If the spin is up, nothing happens. If the spin is down, a lethal mechanism activates. According to the many worlds logic, their consciousness would forever follow the branching path where the atom's spin was up. From their own subjective point of view, they would survive attempt after attempt, seemingly confirming their immortality. But from the perspective of everyone else of the outside world, this is a gruesome and tragic spectacle. In the overwhelming majority of branching realities, the observers would witness the person's death over and over again. This forces a brutal philosophical question. Is the person in the box committing suicide, or are they conducting the ultimate scientific experiment? They are not trying to end their life, but to prove the existence of the infinite multiverse. They are betting their single, local existence against a cosmic truth. Yet, to every friend, every family member, and every law in our society, their actions are indistinguishable from self-destruction. The experiment creates an unbreakable subjective bubble. You, as the subject, would only ever experience the success. You would step out of the chamber again and again, unharmed, with data seemingly proving that you cannot die by quantum chance. But this proof is completely personal and utterly unfalsifiable to anyone else. An outside scientist could never verify the result because they can only observe you in the timelines where you lived. In all the other branches, you are dead, and they are left with a corpse and a failed experiment. This makes the entire endeavor a solipsistic nightmare, a journey into a private reality where your continued existence feels like a law of nature, while the rest of the world sees only madness and loss. The ethical horror lies in this irreconcilable split. You might feel like a pioneer on the verge of a monumental discovery, but to the vast majority of the multiverse, and to all the people who love you in this one, you are simply gone. This is not a path to knowledge, but a descent into a terrifying isolation, where the search for cosmic truth comes at the cost of your shared humanity. That search for a cosmic fingerprint brings us to the 22nd shocking secret, a hunt for evidence written in the oldest light in the universe. The cosmic microwave background radiation is the faint, cold afterglow of the Big Bang, a snapshot of the infant cosmos. For the most part, this radiation is remarkably uniform, a smooth sea of microwaves, but upon this smooth canvas, scientists have found strange and compelling blemishes. The most famous of these is the cold spot, a vast region of space billions of light-years across that is significantly colder than its surroundings. This is not just a random fluctuation. Its size and temperature are so statistically unusual that it challenges our standard models of the cosmos. One breathtaking explanation is that we are looking at the cosmic bruise left by a collision with another bubble universe in the distant past. Here is how it would work. Picture our universe as one bubble and a neighboring reality as another, both drifting in the inflating multiverse foam. If they gently bumped into each other long before the cosmic microwave background was released, the collision would have transferred energy out of our region of space-time and into the void between the bubbles. This energy drain would have left a distinct cold patch on our sky, a circular shadow in the primordial heat. The cold spot is exactly the kind of signature such a titanic event would create, a ghostly handshake from a cosmos we can never otherwise see. But the anomalies do not stop there. Scientists analyzing the patterns in the microwave background have found another strange feature, often called the axis of evil. This is an unexpected alignment in the largest fluctuations of the radiation, a preferred direction in space that should not exist if the universe is perfectly uniform. Why would the universe have a preferred axis? One provocative idea is that the gravitational pull of a colossal neighboring universe, lying just beyond our observable horizon, is subtly tugging on the entire structure of our cosmos, imposing a direction on the primordial soup. It is as if our entire universe is leaning slightly, drawn by the immense, unseen mass of a sibling reality. The quest for proof is now in the hands of our most powerful space observatories. Missions like the Planck satellite have collected exquisitely detailed maps of the cosmic microwave background, and researchers are scouring this data with sophisticated algorithms, searching for the specific patterns that could only be explained by a collision with another bubble. They are looking for not just one cold spot, but for multiple concentric rings, the telltale ripples from a more complex interaction. Every strange alignment, every unexplained cold patch is a potential clue. We are no longer just theorizing about the multiverse. We are forensic scientists at the scene of the Big Bang, looking for the fingerprints of other realities on the very birth of our own. But even this cosmic lottery of 10 to the power of 500 possibilities faces a new and profound constraint. The seemingly infinite landscape of string theory may be surrounded by an impassable swamp. The idea of the swampland confronts a fundamental question. Are all of those 10 to the 500 mathematically possible universes actually physically real? The startling answer may be no. The swampland is the name for that vast collection of seemingly possible universes that, upon deeper inspection, are actually inconsistent with a full quantum theory of gravity. They are the mirages in the desert of mathematical possibilities, cosmic blueprints that look good on paper but could never be built into stable, functioning realities. They are, in essence, the failed states of the multiverse. Think of it like this. You could design a beautiful skyscraper on a computer that defies the laws of structural engineering. It might look magnificent, but it could never be constructed in the real world without collapsing. In the same way, a universe in the swampland might have a mathematically elegant set of laws, but those laws would be self-defeating, leading to irreconcilable paradoxes or instant collapse if anyone tried to manifest them. This is where the swampland conjectures come in. These are a set of proposed rules, deep principles derived from our best attempts to understand quantum gravity that act as a cosmic building code. They are the criteria that aim to distinguish the habitable landscape from the treacherous swampland. One of the most discussed of these conjectures deals with the strength of dark energy. Our universe has a very small positive cosmological constant, which drives its accelerated expansion. The swampland conjectures suggest that a stable universe with a positive cosmological constant cannot have that value be arbitrarily small or constant for all time. If this conjecture holds, it would mean that universes like ours, with their specific tiny amount of dark energy, are not just rare, but may be perched on the very edge of what is physically possible, bordering the swampland itself. This dramatically reshapes our vision of the multiverse. It is not a lawless, random assemblage where anything goes. Instead, there appears to be a hidden architecture, a set of deep meta-laws that govern the entire ensemble. The apparent randomness of the cosmic lottery is not absolute. It is channeled and guided by these fundamental principles of quantum gravity, which act as a cosmic sieve, filtering out the logically inconsistent worlds and allowing only a specific subset of possibilities to truly exist. The multiverse might be vast beyond comprehension, but it is not infinitely permissive. Its wild diversity is constrained by a hidden order, a set of rules for reality itself that even the multiverse must obey. Our universe appears perfectly tuned for life, yet we are surrounded by an unsettling cosmic silence. This is the Fermi paradox, the profound contradiction between the high probability of alien civilizations and our complete lack of any evidence for them. The multiverse offers a startling new lens on this mystery. The reason we might be alone is not because life is impossible, but because a universe like ours is an incredible cosmic fluke. In the vast landscape of the string theory multiverse, with its 10 to the power of 500 different possible sets of physical laws, the overwhelming majority of universes are stillborn. They are cosmic deserts where the nuclear forces are too weak to form atoms, or where gravity crushes any structure before it can begin. In this grand perspective, the silence is not strange at all. We are not hearing from others because in almost every other universe, there is no one home to call out. Even within our own life-permitting bubble, the path from simple chemistry to a civilization capable of spanning stars may be littered with existential traps. Perhaps intelligent life routinely emerges only to be snuffed out by asteroid impacts, gamma-ray bursts, or its own self-destructive tendencies before it can colonize the galaxy. We could simply be the first or the last to reach this stage in a cosmic cycle of birth and death, but there is an even more mind-bending possibility. What if advanced civilizations do not die out? What if they simply graduate? A species millions of years more advanced than us would have likely mastered the physics of the multiverse itself. Confronted with the eventual heat death of their own universe, or simply driven by an insatiable curiosity, they might discover how to engineer a passage into the bulk, the higher dimensional space that separates cosmic bubbles. They could be migrating en masse to younger, more energy-rich universes, or even learning to create their own custom-made realities from scratch. Our universe, from their elevated perspective, might be a quiet backwater, a nature preserve they have no interest in colonizing. The Great Silence, then, is not a sign of our solitude, but a clue that the most advanced beings have moved on to a playground of realities far beyond our own. That profound silence among the stars forces us to look inward, to the very core of our own human psychology. The 25th shocking secret is not about the cosmos, but about us, and how our minds might fracture under the weight of an infinite reality. Truly believing in the multiverse could trigger a deep existential crisis, a form of cosmic nihilism. If every choice you make spawns a universe where an alternative you made a different decision, then what is the point of any single action? Your struggles, your triumphs, your most agonizing regrets, all are rendered simultaneously trivial and eternal. In one universe, you aced the test, and in another, you failed. In one, you married your childhood sweetheart, and in another, you never even met. If every story is told, then the unique value of your personal narrative seems to evaporate into a sea of infinite alternatives. This perspective can drain life of its stakes, making our cherished sense of free will feel like an illusion, a mere menu from which different versions of us are forced to order. Your identity itself becomes fluid and fragmented. Are you the real you, or just one copy among an infinite number, each convinced of their own primacy? This knowledge could erode our sense of responsibility. Why strive to be better? Why work to fix your mistakes in this world, when somewhere else a version of you already has? The moral weight of our actions feels dangerously light when every bad decision is counterbalanced by a good one in a parallel reality. Yet, this very same infinite tapestry can be a source of profound liberation. The crushing burden of regret, the haunting ghost of the road not taken, could simply dissolve. That career you did not pursue, that risky conversation you avoided, that dream you let slip away, you can take solace in the fact that somewhere in a universe just a branch away, another you is living that life fully. Your unlived lives are not lost, they are being lived. This can free you to fully embrace your current path, not as the only one, but as your unique thread in an unimaginably rich tapestry. It transforms regret from a painful wound into a quiet acknowledgement of life's boundless possibilities. The final psychological frontier is our own mortality. The concept of death becomes terrifyingly ambiguous. If quantum immortality holds any water, your conscious experience might always follow a path where you avoid the end. But even without that, in a multiverse where everything that can happen does happen, the you that dies is just one version. An infinite number of other yous continue on forever. This does not make death in this world any less real or painful for those who remain, but it introduces a dizzying new dimension to the end of a life. The ultimate question is whether humanity is psychologically equipped to handle this truth. Our brains evolved to navigate a single, linear reality with clear cause and effect. The multiverse theory shatters that framework entirely. Internalizing it could lead to a collective paradigm shift as profound as the Copernican revolution, one that redefines our place in existence not as the center of one story, but as a single reader in a library containing every story ever written. It is a knowledge that could either cripple us with insignificance or empower us with a breathtaking sense of cosmic connection. This paradox strikes at the very heart of physics, suggesting our two most successful theories are fundamentally at war. On one hand, quantum mechanics insists that information is sacred, never destroyed. The exact details of every particle that falls into a black hole, its type, its spin, its energy, must be preserved in some form. You could think of information as the ultimate cosmic recipe. If you burn a book, the information is not truly gone. The specific arrangement of atoms that form the letters is transformed into smoke and ash, but in principle, if you could collect every single particle and trace its path backward with perfect precision, you could reconstruct the entire text. Quantum mechanics demands this same principle applies to a black hole. Yet, general relativity paints a different, terrifying picture. It describes a black hole as a place where space and time simply end at the singularity. Anything that crosses the event horizon is irretrievably lost, crushed out of existence. The black hole itself only possesses three simple properties: mass, spin, and charge. It does not care if you throw in a grand piano or a cloud of hydrogen gas. If both theories are correct, we face an impossible contradiction. Either information is permanently destroyed, violating quantum law, or general relativity's description of a featureless singularity is profoundly wrong. The multiverse offers a breathtaking escape from this deadlock. What if the information is not destroyed at all, but simply moves somewhere else? The proposal is that deep inside a black hole, the gravitational collapse does not culminate in a singularity. Instead, the extreme warping of space-time triggers the birth of an entirely new universe, a baby cosmos that pinches off into its own separate region of the multiverse. All the information about the grand piano, the cloud of gas, every single particle that fell in, is not erased. It is encoded into the initial conditions of this newborn reality. The black hole is not a tomb, but a cosmic womb. This idea transforms our universe from a solitary island into a prolific mother. Every star that collapses into a black hole could be giving birth to a new cosmos, each with its own unique history written by the specific information that seeded it. This provides a stunningly elegant solution to the paradox. The information is preserved, satisfying quantum mechanics, but it is permanently sequestered in a baby universe that is causally disconnected from our own, which from our perspective makes it seem as lost as if it had been destroyed. We can never access that information again because it has become part of the fundamental laws and initial state of another reality. This means the vast, dark black holes scattered throughout our galaxy are not in points. They are gateways, each one a silent genesis event for a new world in the infinite expanse of the multiverse. The relentless forward march of time feels like the most fundamental rule of existence. Yet this arrow of time, pointing inexorably from an ordered past to a disordered future, might be nothing more than a local custom in our corner of the multiverse. Its origin is one of physics' deepest puzzles, solved only by looking back to the very beginning. Our universe was born in a state of incredibly low entropy, a condition of exquisite order and simplicity. Think of a brand new deck of cards perfectly sorted by suit and value. This was our cosmic starting point at the Big Bang. Over billions of years, that deck has been shuffled, spreading out into the messy, high-entropy state we see today, with galaxies scattered and energy diluted. The reason we remember the past and not the future is because the past was always more ordered. This is the past hypothesis, the idea that time's arrow is a direct consequence of our universe's special initial conditions. But why did our universe start in such an orderly state? The multiverse offers a radical answer. In an infinite ensemble of cosmic bubbles, the starting conditions are not a unique, finely tuned miracle. They are a random draw from a vast distribution of possibilities. Our universe did not win a special lottery for low entropy. It is simply one of the relatively few bubbles that, by pure chance, began with the order necessary for complexity to later arise. In this grander view, the arrow of time is not a universal law. It is a local and contingent feature of our particular cosmic address. So what does time look like in other universes? In the vast majority of cosmic bubbles, the initial entropy would have been high from the very start. In those realities, the deck of cards was pre-shuffled into maximum chaos. There, the concept of a past and future would be meaningless, as no change in disorder could ever occur. Beings in such a universe would perceive a static, timeless existence with no memory and no possibility of cause and effect. Other universes might have a cyclical arrow of time, expanding and contracting in endless cycles, where entropy resets at each new Big Bang, creating a perpetual loop of cosmic death and rebirth. And then there are the truly alien possibilities. Some universes could have time that runs backward from our perspective. In such a realm, you would remember the future and watch shattered glasses reassemble on tables. The very laws of cause and effect would be inverted. Our own experience of a one-way temporal street is not a fundamental rule of reality. It is merely the way things happen to be in this one bubble, a fleeting direction in an ocean of timeless and multidimensional realities. Our most advanced scientific theories seem to echo whispers from our most ancient traditions. The 28th shocking secret reveals that the concept of a multiverse is not a new invention of physics, but a profound intuition that has haunted human spirituality for thousands of years. Long before telescopes or particle accelerators, mystics and sages were describing a cosmos of staggering plurality. In Hinduism, the supreme reality, Brahman, is described as endlessly manifesting innumerable universes, each one a self-contained Brahmanda or cosmic egg. These countless creations are said to be breathed in and out by the divine in a cycle that lasts for trillions of years, a rhythm of cosmic inhalation and exhalation that mirrors the scientific concepts of eternal inflation and cyclic brain collisions. Each Brahmanda has its own gods, its own laws, and its own timeline, a direct parallel to the bubble universes of modern cosmology. Buddhism, too, speaks of countless world systems spread throughout the 10 directions of space, each with its own conditions for suffering and enlightenment. These are not mere metaphors for different planets, but entire realities, realms of existence with fundamentally different properties, much like the distinct domains in the string theory landscape. The sheer scale of this ancient vision is breathtaking, a spiritual multiverse where sentient beings journey through an infinity of worlds across countless lifetimes. In the mystical traditions of Islam, particularly in Sufi thought, there is a concept of a multitude of created worlds, or alam, each a unique manifestation of divine attributes existing in layers beyond our sensory perception. Similarly, certain streams of Jewish Kabbalah describe a tree of life whose structure implies a multiplicity of cosmic realms, or olamot, each a different emanation of divine light and a different stage in the process of creation. These are not simple heavens and hells, but complex, coexisting planes of reality. The stunning parallel to the quantum multiverse is unmistakable. The many worlds interpretation, where every possibility branches into a new reality, finds a deep resonance in these ancient ideas of layered existences, where every divine thought or potential is instantiated in its own world. It is as if the human spirit, in its deepest contemplations, always sensed that our familiar reality was just one page in an infinite library. Science, with its mathematics and its evidence, may now be building the formal scaffolding for this age-old vision. We are not discovering the multiverse for the first time. We are remembering it and finally beginning to understand the language in which its truths have always been written. This connection does not validate any specific religion, but it does suggest something profound about our species. Our drive to understand the cosmos, whether through prayer or through physics, has always pointed toward a reality of unimaginable vastness and diversity. The multiverse may be the meeting point where our oldest wisdom and our newest science finally converge. The profound spiritual echoes of the multiverse confront a staggering technological possibility. If other realities exist, could we ever reach out and touch one? The engineering required would dwarf anything we can conceive, demanding power on a cosmic scale. A civilization capable of such feats would likely be a Type 4 or even Type 5 on the Kardashev scale, having transcended planetary and stellar power to harness the energy of entire galaxies or the multiverse itself. Their ultimate project might be metric engineering, the deliberate warping of spacetime itself. To bridge the gap between cosmic bubbles, they might need to stabilize a wormhole, a tunnel through the higher dimensional bulk. This would not be a gentle process. It could require the focused energy of a spinning black hole, or the complete conversion of a star's mass into pure, structured power to hold the throat of the wormhole open against its natural tendency to collapse. Imagine a Dyson sphere not around a single star, but around a quasar, capturing a significant fraction of its titanic output to power a single, unimaginable experiment. The goal would be to create a stable conduit, a cosmic subway tunnel connecting our brain to another. But what would we find on the other side? The existential risks are as immense as the energy requirements. Poking a hole into a neighboring bubble universe could be an act of catastrophic cosmic contamination. The fundamental constants might be different there. The very vacuum of space in that other reality could possess a higher energy state. Creating a connection could trigger a phase transition, a lethal wave of new physics that would rush through the wormhole and into our universe, rewriting the laws of nature at the speed of light and obliterating everything in its path. Our peaceful cosmic neighborhood could be instantly transformed into a hostile, alien environment. Even if the physics were compatible, the ethical questions are profound. Would we have the right to interfere with another universe's independent timeline? Would making contact be an act of exploration or an unforgivable invasion? A truly advanced civilization might not see the multiverse as a collection of foreign lands to be conquered, but as a sacred library of existence to be observed and preserved. They might choose to remain silent, not out of inability, but out of a deep cosmic wisdom. The ultimate technological frontier may not be about building the engine to get there, but possessing the maturity to leave the infinite alone. This final frontier is not about new realms of reality, but the very limits of science itself. The ultimate secret of the multiverse theory is the unsettling charge that it might not be science at all. If these other universes are permanently sealed away from us, beyond any possible observation or measurement, then is the multiverse just a beautiful piece of metaphysics, a philosophical speculation disguised as physics? Critics argue that for an idea to be truly scientific, it must be falsifiable. It must make predictions that could, in principle, be proven wrong. How can you ever disprove the existence of something you can never see, touch, or interact with? This is the core of the crisis. If every unexplained phenomenon can be attributed to the whims of an unseen multiverse, then the theory risks explaining everything and therefore nothing at all. It could become a cosmic catch-all, a place where scientific puzzles are not solved but simply dismissed as quirks of our local cosmic neighborhood. The fear is that we might be building a cathedral of ideas on a foundation that can never be tested, retreating from the hard, empirical work that has defined scientific progress for centuries. Yet the scientists who champion these ideas are not blind to this challenge. They propose a different kind of evidence, a case built on cosmic forensics. We may never visit another universe, but we might find its fingerprints all over our own. The mysterious dark flow, that coordinated river of galaxy clusters, could be the gravitational tug of a massive neighbor. The strange cold spots and alignments in the cosmic microwave background might be the bruises from a long-ago collision with another bubble. The breathtaking fine-tuning of our physical constants, which seems so inexplicable in a single universe, finds a natural home in a multiverse where such rare, life-permitting conditions are a statistical inevitability. For proponents, this is not a retreat from science but an expansion of its methods. They argue that when dealing with the ultimate nature of reality, we must follow the evidence where it leads, even if that evidence is indirect. The multiverse, in this view, is the best and most parsimonious explanation for the strange coincidences we observe. It is the solution that makes the puzzle pieces of modern physics snap together. This forces a profound philosophical question. Must our definition of science evolve when confronting realities that are, by their very nature, beyond our direct reach? Is explanatory power, the ability to make sense of a host of otherwise bizarre observations, a form of evidence in itself? The debate is a fiery one, a battle for the soul of physics. It asks whether we are brave enough to accept a reality whose full majesty we may only ever glimpse in shadows and reflections, or whether we must insist that all true knowledge must fit within the confines of our single, observable cosmos. Where, then, does the final line lie? Is the multiverse the next great paradigm, a necessary step in our understanding, or is it the point where science finally dissolves into unprovable philosophy? The answer, for now, remains the most tantalizing secret of all. From the quantum splitting of your every choice to the cosmic Darwinism of black holes birthing new realities, this journey through 30 secrets has redefined existence itself. We have wandered through infinite libraries of mathematical possibility, grappled with the terrifying solitude of Boltzmann brains, and stared into the abyss of our own fragmented identities. The multiverse theory, in all its speculative grandeur, stands as a testament to human curiosity, a monumental effort to push past the edges of our cosmic map and ask what lies beyond the beyond. It forces a collision not just of brains, but of physics and philosophy, of science and spirit, challenging the very definitions of reality, consciousness, and our place within it all. While the debate over its scientific validity rages on, its true power lies in its capacity to shatter our preconceptions. It reveals a cosmos or a multiverse of boundless, breathtaking wonder, far stranger than any fiction. The greatest secret uncovered here is not one of the 30, but a singular, humbling truth that the adventure of discovery has only just begun. The mysteries waiting in the shadows of reality are endless. We want to hear which of these secrets reshaped your world the most. Tell us in the comments below what idea left you utterly stunned, and subscribe to continue exploring the deepest wonders of the cosmos.